Look at that branding, guys. Yeah, that's right. I got another Osprey FPGA miner, and they have upped their branding game as well, just like Ice River. So nowadays they come in these nice white boxes. This is actually not a brand new, so I utilized their Reball services, which is essentially giving them old FPGAs, whether it's an like you could submit. There's a bunch of different ones. You should definitely reach out to them first to make sure that what you have is compatible. Your FPGA needs to be a certain package type to be utilized in their boards, but they do take certain VU9P, VU13P, VU33P, and VU35P chips and will reball them, which is the process of taking them off the boards they're on, whether they're faulty or not, taking them off, putting all the new, they're like little solder balls on the back of the chip, and essentially putting it onto their board that goes inside of their unit so that you can use like an FK33 could now be an E200 miner. So it's a way of bringing new life to older things, or if they were already working, just to simplify things because the E200 chassis is pretty streamlined. Now, obviously, if you did have an FK33 or a U50C or something like that, you do lose some flexibility doing this because now you're kind of dependent on Osprey to release bit streams to a certain extent. That's not 100% true because you can SSH into these units and then essentially apply any bit stream you have access to that works for the chips you have. But that obviously requires some knowledge of Linux, and which you would probably have if you were already running FPGAs. So there is still a way to do it. It's just a little more convoluted. But if you're really looking for optimizing, which with how much equipment I have in my whole farm, I'm always looking for ways to optimize my operations. FPGAs, traditionally like FK33, are kind of annoying to run, to be honest. In bulk, it's definitely a little difficult. So I had some U50Cs specifically that I wanted to get reballed just so I can more quickly, manage my farm and my FPGAs. So a really nice box, though. We're going to open this up. This is actually going to be an E200. There we go. You can see I got two boards in there. I had two U50Cs, so got them reballed, and nice to see them in there ready to go. Now, which does kind of get me to the bigger thing. So this has two boards, and I have another E100, E300, whatever you want to. Again, the number after the E is just how many boards you have. So this is technically an E200. But I got another shell in that box, and that's because over here you can see my other E300s. These both have three boards. The one board is really narrow compared to the others, as you've seen in my prior videos on these, and I'm not a big fan of that. So I actually bought an additional shell that I have been meaning to move the two small boards in these into. And I actually bought larger heat sinks from Osprey for them too. So essentially I'm going to end up with four E200s in the end, with all boards having the larger 27 millimeter heat sink. But that's something I still got to do down the line. But this is kind of step one, and this will be my first E200 miner of the four. So nice to see this here. Again, they have some of the nicest packaging, and they just make FPGAs really simple. So really nice handbook here. I'm not going to go through this. Went through it in a prior video. But yeah, even this is good quality paper. They just do a good job. Really impressed with these guys. So yeah, we're going to get this out here and then start mining. So so I got it out of the box here. And one of the first things I noticed is they put my name on it. So that's kind of, I like that. And then you can also see that and you should do this if you're not running 3, it's fill this in just to make sure the wind tunnel effect stays in full force. Unfortunately, it looks like, and again, these the Reball service is overseas. It does look like I may have lost another one of these small heat sinks. I did a repair video on these. So I am going to open this up. I have to anyway because there's a spacer in here for shipping. But I'm gonna pull out these boards and see if one is indeed missing. I'm gonna guess it is because I found this in the box. But we'll see in a moment. All right, we got the back off here, and you can see, like I said, they did put spacers in here for shipping. That's just so things don't rattle around and go all over the place. So they do recommend taking these out, mainly because they're probably not heat resistant. Now, I am curious how these are going to run. Typically, for any type of ASIC chassis like this, you kind of want dense spacing so that there's essentially air is like water. It's always going to take the path of least resistance, right? So now that this is a wind tunnel, air is not going to go through these fins as much as if, say, there was something here. Obviously, this is not meant for that, so I have to take it out. But I am curious when I start running these if like this board will run a lot warmer than the adjacent board, just because air is more likely to go around the heatsink than through it. And if that's the case, I've been thinking of putting like a not this type of foam, but like insulation foam, like cutting a block to size and putting it in here. But we're going to see how it runs first and see if there is a big temperature difference. If there isn't, I mean, it's not worth my time. But in theory, it will probably need something. But yeah, so we're going to slide these out now, though. Like I said, I'm kind of need to figure out where this heatsink came from. I'm not 100% sure. I mean, it'd be awesome if it was just like extra and just fell in accidentally, but I doubt it. I mean, shipping is not fun. So, oh look, I like that they even labeled my boards, and that's how I think they keep track of like what chips you gave them. So, let's see, are we missing any? It looks like this one's falling off. We're going to have to fix that. So I'm just going to peel that off too. Normally, I can't remember how many there are. I think there's supposed to be one there. So I do think this is the board. I think there's supposed to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But I could be wrong. We'll check the other board. So we know that this one had 12, because that one fell off. Let's see what the other board, or 10, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll see what's on this other board, if this one has 10, or if, no, that's where it came from. I see it right there. Alright, so yeah, we got a loss of a heatsink on both, unfortunately. Which means today I'm going to re-glue these, and then they're going to have to set overnight. So we're going to hop ahead in the video till tomorrow, and that's when I'll get these up and running. So, be right back. Alright, so we're back at the farm. It's a day later. Got our heatsinks glued on, ready to go. So we're just going to throw this guy on the shelf and get it mining. Over here I got a small APW 3 or 7 PSU Bitmain. Only need 5. Since I only got 2 boards, only need 5. I do have to turn this around because it kind of blows air the opposite direction you would expect, as I've previously mentioned. Again, the intake's near the chips, because the chips sit at this end of the heatsink, and then the length of the heatsink goes down the whole thing and exhausts out the front. So that's kind of the setup we're going to roll with here. I think I got a single. There we go. We actually got 2 singles, but whatever. That's okay. We might have to put the PSU on that side. Yes, that's what we're gonna do. I think. I don't know. Maybe on the other side. I can't decide. What makes more sense? None of the above. I think this side will make the most sense. Yeah, so you got, like I said, 1 6-pin for the control board, Trying to find the longest one. No, that one's even shorter. So we'll use this one, I guess. We'll use this one. Alright, got one plugged in. So just need to plug in these two boards. So they each get, let's see, do we have one of these prongs that has exactly 4? No, that one has 3. Could have 4. They're tied together though for some odd reason. So we're almost ready here, except I forgot I need a power cord. So need to go grab one of those real quick. And then we'll get going here. So we got this plugged in. Should be ready to go. I'm actually putting this on 120 volt just because it's so low power since it's just 2 boards. But you definitely, obviously depends on your PSU what you can do. All right, plugged it in. You can see we got 2 green lights, so that's a good sign. We're gonna hop on over to computer, see if we can find this guy. All right, guys. As you can see, we found it in our IP address and was able to log in. And you can see that there's 2 boards registered and 1 empty. So board 0 is always the narrower heatsink. A couple housekeeping things I always do immediately. 80 is the temperature that I like my things to max out at. So we're going to do that real quick. You can see that adjusted maximum temp there. You can see that these are VU35P CIVs. So that's a little different than my other one. My other ones are VU35Ps. That's because these came from, what's it called, from a U50C, which has a slightly different package. Sorry, the package is the same. The chip ID is slightly different. So just something to note there. We're going to be mining Radiant. So we can drop our millivolts on the HBM down to 1000 because we don't need it. And we're going to be using the higher overclock, so you can find recommended overclocks in their Discord. My other chips have been doing a little higher than that. I've been doing 590 millivolts and a clock of 560, but I'm going to start off with their recommended high just to see how these chips are doing before going anything too crazy. So again, that's 550 on the clock, 750 on the megahertz. So we're going to do 750, not megahertz, millivolts. Never mind. You know what I meant. So once those turn to 750, we'll get going on the mining side. So right now it's already doing. We're going to stop. All right. So I guess it was already on Radiant, which is awesome. We're going to copy over my miner settings. No big deal. We're going to do that. We're going to go over here. Woo, and copy that. And our worker ID, I've been using what the unit is. So my other ones are currently still E300s, but this one's actually E200 and E235 because it has the VU35P chips, and it's actually 1624 is the unit number, so that's what we're going to use. And then this one's going to be 550 on the clock. Everything else looks great, so we're going to press start, and it should start loading up our bitstream here. I guess I should have checked if this is on the latest firmware. Hopefully it is. Yep, it's on the latest firmware, so you can see that both my versions are running that. So I'm going to bring up the logs on my other one just for a comparison. So this one's doing about 11.38 consistently. So we'll see what this one does on slightly lower settings. And if it does well, we'll up it to those higher settings. All right. So we've officially started mining on my Reball chips. We'll let it ramp up and see how it goes. I do want to quickly make sure the fan settings are what they should be. I always do auto because, well, these are the levels. It's nice that you can set it by level, and I think I've always just stayed with the default because essentially it almost always gets up to the 100% fan speed. Um, I guess the default settings are a little different over time, so that's kind of interesting. So, yeah, a little more aggressive on the new unit. Maybe I should change my old unit. All right, so it's been running for maybe 5 minutes or so now. It looks like we're doing pretty decent, to be honest, on everything. No real complaints. Well, maybe a tad bit slower than the other one, but again, that's because I have lower clocks at the moment. So I think I'm going to match the clocks on my other unit and see how it does. Maybe I can do it with less voltage, though. Maybe I can hit 560 at my current voltages. We'll see. Let's take a pass here. All right, I'm gonna take a few minutes for this to load. So it has admittedly been a few days, maybe a little longer. I literally have so much going on right now that I have such a backlog of content that I need to edit and get through that I completely forgot about finishing this video. So, and I kind of cut to nothing when I ended, and I just realized this when I was trying to edit, all my clips and combine clips and so on and so forth, and realized there was no end to this video. So, we're back at the farm today, and you can see that I have found settings that I really like for my two VU35P CIV cards that we have seen earlier in this video. So I found that right around 780, so these are programmed for 780, they're going to hover around that millivolt mark, just depending on the exact moment. So 780 millivolts and 570 on the core clock seem to be the sweet spot for the cards I have. They're doing real well, averaging over, it's been days at this point, but you can see here, averaging 7.5 plus 7.56 to be, honestly, it's really, really steady. 7.56 gigahash total on radiant between the two cards, which is right around 3.7, 3.8 per card. They've been super stable, very low hardware rates. I could have lower hardware rates, so hardware error rates. When I did 560 and the current millivolts, it was absolutely zero errors, but the hash rate was, at about half a gigahash less. So for barely any more errors, I'm able to achieve about, from 7 to 7.5 is a big amount. So, I'll take it. I did try going higher at one point. I think I put it up to 580, and this hardware error number started to climb into the mid single digits, 3 to 5%, which is definitely too high. So knocked it back down to 570, keeping the current, voltages. I did try some super outliers, like really bumping up the voltage into the 800s and really going for it. But the VU35Ps, in my experience with the other ones on Radeon as well, Uh, it's very quick diminishing returns when you get up into the high millivolts versus the higher clock speeds. Like, you really don't see much of boost beyond this 3.6, 3.7, 3.8 mark on your gigahash for VU35P. The highest I've ever seen it get is like 3.9, 4.1 maybe, but at significantly more wattage, like massive amount of wattage. Like I said, probably needed like 840 on the millivolts, which not only is way more wattage at the wall, but it's also way more heat. I don't like to run things at full bore. These are nice and cool at 60 and 57. And this is actually a good time to look. So this has been running for a while now. So that one card that has that vacant space next to it is running hotter. So my hypothesis on that is indeed true. You know, since that one slot is open, the air is not being forced into the fins of the heatsink as much. So it is running a little hotter. So I think long term, I'll definitely want to add that in, that a little spacer to fill in that void. I'm not going to do that today because actually I'm kind of reworking a lot of things. I have a ton of stuff coming. I have like a ton of BC250 rigs coming. Have some ASICs coming. Got a whole bunch of stuff coming, and now that I'm gonna convert all my E300s into E200s with 2 boards each, I think I'm actually gonna move them to my house, which is gonna require me to swap off the high velocity fans on them. I'll switch them to Noctuas, which obviously will increase my chip temp, so it'll be very important to make sure that I am adequately getting air into the fins of this board 1 heatsink. But that's, you know, going to be for a different video, different day. So that's all I got for the final overclocks I've set for my VU35P CIV cards that were Reball. Thanks, Osprey, for the Reball services. I think it's super awesome. Link down below for you guys that have thought about doing Reball services. This is last call for the VU9P and VU13P. There's just not enough demand. Those are really old at this point. So they're just not going to be doing those going forward. The VU33 and 35Ps have at least one more batch, I'm told. But you never know. Again, it is all just supply and demand related. And all these FPGAs are honestly getting a little old at this point. I'm curious if Osprey will ever adopt a newer FPGA chip. I don't really know what the latest greatest is from Xilinx, but I am curious if that's on the roadmap for really Osprey or the FPGA mining community in general. Obviously, bitstreams are a ton of work, so for bitstream developers to really target a new chip, there has to be enough demand, which means there has to be enough adoption of said chip. So it's a really weird situation to move off of something. That's why the FK33s have been around forever at this point. They're super old technology, but you know, there's a ton out there, and it's a reliable way for devs to get income to support them. Whereas any new chip that comes in the pipeline for FPGA mining is really quite risky. So, but yeah, that's all I got on this for today. So comment down below thoughts. If you're going to do any reballing of your prior FPGAs to optimize in an E200 chassis, like, subscribe, and that's all I got. Until next time.